Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about Schrodinger wave equation in 3D box. So let us start learning with the Bohr's atomic model. You can see the model of Bohr atomic orbit, nucleus, electron of oxygen. You can see the n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. This is the principal quantum number. And you can see the jumping of energy, means energy difference between two orbit. So what is the drawbacks of Bohr's atomic model? According to Bohr, the electrons revolve around the nucleus in certain well-defined circular path, which are called as orbits. But uncertainty principle given by Heisenberg overruled the existence of orbits, and it is not possible to measure simultaneously both position and momentum for a microscopic particle with absolute accuracy. Then you have this formula del x del p greater than is equal to h by 4 pi, and del x is equal to uncertainty of position and del p uncertainty of momentum. So because of the following reason, this principle introduced the idea of a character of an electron in addition to its particle character. Using wave character, this rule pointed out that the path of an electron cannot be well defined. To overcome these drawbacks, scientists developed a model which would incorporate dual character as well as uncertainty principle. Now you understand the some history of this chemistry. Now quantum mechanical model of an atom developed by Werner Heisenberg and Erwin Schrödinger in 1926. You can see dou square psi by dou x square plus dou square psi by dou y square, dou square psi by dou z square plus 8 pi square m h square e minus v psi is equal to 0. So you can see here in this formula second derivative with respect to z and second derivative with respect to x and y. Now this one is representing position, so Schrodinger wave function psi. This is indicating energy, this is the potential energy. So the wave equation, the de Broglie equation is known as the wave equation. You know lambda is equal to h by mv or is equal to h by root 2 E energy of electrons in mass, and amplitude of vibration and t time. So omega is equal to fx gt, equation 1, Cartesian coordinate, and gt is equal to a sine 2 pi pt. So differentiating the equation 1, you will get the equation 2 and 3. So from equation 2 and 3, we have here del square of fx by dx square is equal to minus 4 pi square lambda square fx. So above equation represent wave motion in a x direction only. So to extend the motion in three direction x, y, z, fx is replaced by psi x, y, z. Now the equation become like that. You can see the equation 5. Now introducing de Broglie relations in the above equation, you will get this. Now E minus V is equal to half mv square. So V square is equal to minus 2 EV minus V by m. Sub the value in equation, substitutes. Then you will get the equation 8. Equation is known as, it is known as wave equation, Schrodinger wave equation. Now kinetic energy and potential energy is equal to E. Half m square, half k square. In harmonic oscillator examples, this is the energy. F is equal to ma minus kx, that is the classical. Now p square by 2m plus half kx square, the energy becomes the Hamiltonian operator. Here you can see h psi is equal to E psi wave functions, E energy eigenvalue for the system. Now P is equal to H cross by I do by dx, x tend to x, and H is equal to minus H cross square by 2m del square by 2x square plus half kx square. You know the form of the Hamiltonian operator for quantum harmonic oscillator. Now particle inside 3D box, you can see. So time independent Schrodinger wave equation. This is the parameter only we have changed. So assuming that the wave function is a product of three parts which separated depends on xyz. So this is the separated part. So substitute equation 2, 3 in equation 1. The equation is divided by h 2m by h square. The result equation become like that. So above function is depends upon the direction mentioned and it independent of all other directions. So the above equation can be written as follows for motions calculation along the three direction. You can see. So to calculate the total energy Ex, Ey, Ez, from 1D box calculation energy of the particle can be written as follows. So you can write Ex, Ey, Ez. So total energy of particle inside the 3D box is given by this equation. So thank you. If you like this video, then subscribe my channel and thanks for watching.